So let's go ahead and start setting up our Quart counter application. Like I've done in other courses, we're going to build a web application that stores a counter in the database and increases it by 1 every time you reload the page. This will allow us to see how a typical Quart database application is laid out. Let's initialize the Poetry environment with Quart. You should have Poetry installed from the previous module. So cd to the backend service folder and type the following command in your terminal. This will generate our initial PyProject TOML file, but we need to modify it to match our application requirements. You'll notice we're pinning specific versions for some of our dependencies. We're using Quart version 0.184, which is stable and works well with our application. We're also specifying Werkzeug 2.3.7 as it's a crucial dependency for Quart to work properly. Notice the package Dynaconf. Dynaconf allows us to manage configuration settings in a very flexible way. Instead of having multiple configuration files for development, staging, and production environments, Dynaconf allows us to have a single configuration file with different sections. It also allows us to override these settings with environment variables, which is particularly useful when deploying to production or when working with Docker containers. For development, we're adding Black for code formatting and MyPy for static type checking. These are essential tools for maintaining clean, type-safe Python code. Let's add a few more configuration sections. The Build System section tells Poetry how to build our package. We're using Poetry Core, which is the standard build backend for Poetry projects. The Black configuration sets our line length to 88 characters and specifies that we're targeting Python 3.10 compatibility. Finally, the MyPy section configures our type checking tool with some sensible defaults. We're asking it to be quite strict with type checking, which will help us catch potential issues early in development. Save the file. Now let's create our settings TOML file in the same folder, which will contain our application configuration. This is where Dynaconf really shines, as it allows us to have different settings for different environments. Let's break down how this configuration works. The default section contains settings that are common across all environments, things like database credentials and secret keys. These values will be used unless they are overridden in a specific environment section. The development section is used when we're running our application directly on our host machine. In this case, we set dbhost to localhost, because that's where our PostgreSQL server will be running when we're developing locally. The Docker section comes into play when we're running our application in Docker containers. Here we set dbhost to db because that's the service name we defined for our database in our Docker Compose file. When containers are running in the same Docker network, they can reference each other by their service names. Dynaconf is smart enough to know which section to use based on the env for Dynaconf environment variable that we set in our Docker Compose file. When we're running with Docker, it will automatically merge the default settings with the Docker section, overriding any values that exist in both. Save the file. Now let's create our first blueprint that will handle our home routes. Blueprints are a powerful feature in Quart, just like in Flask, that allow us to organize related routes and functionality into separate components. Think of blueprints as mini applications that can be reused across different parts of your main application. For example, you might have a blueprint for user operations, another for admin functions, and so on. First, let's create the main application folder and call it My App and add an init.py inside. This file is what makes Python treat our directory as a package. It's a special file that marks a directory as a Python package directory. Even though it's empty, its presence is what allows us to import modules from this directory. Inside the My App directory, create a new folder called Home App, and inside another empty file called init.py. Now let's create our views.py file in the same directory. This will contain our blueprints, routes, and views. Let's break down what's happening here. First, we create a blueprint instance named Home App. The first argument, Home App, is the blueprint's name, which should be unique across your application. The second argument, name, tells the blueprint where its resources, like templates and static files, are located. Just like in Flask, we use the route decorator to define our routes, but here we use Home App Route instead of App Route, because we're defining routes for our blueprint rather than the main application. All routes defined in this blueprint will be relative to wherever we register the blueprint in our main application. For example, if we register this blueprint at /home, the full URL for this route would be /home/app settings. Notice how we're using the async keyword here. This is because in Quart, all route handlers must be asynchronous. Even though we're not doing any I/O operations in this route yet, we still need to declare it as async. We now finish the route by returning the environment variables for Dynaconf and the database host. The idea is that we have an endpoint to check that everything's working as intended. Save the file. Now let's create our application py file in the My App directory. This file will serve as our application factory, which is a best practice in Flask and Quart applications, as it allows us to create multiple instances of our application with different configurations. Let's walk through this code. First, we're importing the necessary types and modules, including our Home App blueprint that we just created. We define an init.config function that takes a Quart application instance and any configuration overrides we want to apply. It first loads our settings from Dynaconf and then applies any overrides. This is particularly useful when we want to use different settings during testing. The main function is createApp, which is our application factory. Notice that it's an async function. This is because in Quart, we might need to do some asynchronous setup when creating our application. The factory pattern allows us to create multiple instances of our application with different configurations, avoid circular dependencies, and make our application easier to test. Save the file. Now let's create our manage.py file, which will serve as the entry point when we want to run our application locally. This file might look simple, but there's quite a bit happening here. We're using it as an entry point for our application when we want to run it locally, as opposed to running it in Docker. Remember that our createApp function is asynchronous. It returns a coroutine. In Python, we can't just call an async function directly. We need to run it in an event loop. That's exactly what a syncyo_run does. It creates a new event loop, runs our coroutine in it, and properly closes the loop when done. Save the file. Now let's create our asgi.py file. Remember from our Docker file that we specified myapp.asgi.app as our application entry point? This is the file that Hypercorn will use when running our application in Docker. While this looks similar to our manage.py file, there are a couple of key differences. First, we're explicitly adding our parent directory to Python's path with syspath_append. This ensures that our application can be found when hypercorn runs it. Second, notice that we create the app task, but then run it immediately after that. Save the file. The last quick thing to add is a .git ignore file in the root folder so that we don't check unwanted files into our repository. Just copy and paste this file. Now let's verify that everything is working properly. From your terminal, cd to the root directory of the project where your Docker compose YAML file is located, and run docker compose up. You should see Docker building your images and then starting both your web service and the PostgreSQL database. Once everything is up and running, open your browser and navigate to localhost 5001/app-settings. If all went well, you will see a page showing Home Hello World, along with your Dynaconf environment setting and DB host. The DB host should show DB since we're running in the Docker environment. Congratulations, you've just built a solid foundation for a modern async Python web application. We've set up a proper project structure using Poetry for dependency management, implemented configuration management with Dynaconf that adapts to different environments, and created a modular application using blueprints. In the next module, we'll build upon this foundation by adding database migrations. This will allow us to version control our database schema and make it easy to make changes to our database structure as our application evolves. Get ready to explore the powerful combination of Quart and database management.